it would be good to look at one that doesn't work. In fact, you wouldn't need much more than the test for divergence on this one. Suppose it alternates in sign, -1 to the n. N goes from 1 to infinity. If we simply look at what the terms do, the limit, as n goes toward infinity, on the nth term formula, if we divide everything by n, it's true. 3 over 4 minus 1 over n. This goes to 0. It's true that it heads to 3/4. It's not heading towards 0. And by the test for divergence, we cannot apply the alternating series test. The terms are not heading towards 0, therefore the series must diverge. Let's do one more example. N squared over n cubed plus 1. It does alternate. And this is to the n plus 1 power. The question might be, how do we show that it decreases? Again, another approach as opposed to replacing it with n plus 1 and comparing would be to take the derivative and think about what it does. So we think about the corresponding function x squared over x cubed plus 1. And if this is our function, if we go get the derivative for that f prime, we'll skip some of the details, but you would end up with the denominator squared, and the numerator comes down to x and 2 minus x cubed. Again, carry out the quotient rule and this is where you arrive. Denominator squared, so it has to be positive. We're considering positive values, so certainly x has to be positive. When would the derivative be negative? If this piece were negative. So 2 minus x cubed, when that's negative, it would be decreasing. That would mean that 2 is smaller than x cubed. If we flip this around, x cubed is bigger than 2, and if we take the root of both sides, x is greater than the cubed root of 2. So past the cubed root of 2, so from the cubed root of 2 to infinity, the terms decrease. Did the terms head towards 0? Once again, we would take the limit as n goes to infinity on the nth term formula. N squared, n cubed plus 1. We want the limit as n goes toward infinity. Appropriate method would be to divide by n cubed. So n squared over n cubed over n cubed, and 1 over n cubed. Reduce. We get 1 over n in the numerator. Denominator is 1 plus 1 over n cubed. Take the limit. As n goes toward infinity, the numerator heads towards 0. This piece heads towards 0. Yes, the terms are heading towards 0. Terms are decreasing. Terms are heading toward 0. So by the alternating series test, it converges. The sum of terms would converge.